Hey there, this is Salaryman. Let's talk Create. Create is a mod that adds a new spin to the Minecraft experience. The mod works on a simple concept: rotation is power. So if you want to get something to work, you have to make it spin. The mod introduces quite a bit of stuff into the fold, so I prefer to categorize them into the following: power generators, power transmission, power consumers, and accessories that you can use to customize, further automate, and make your assembly line more intelligent. Before we start, I'll be using the following items: engineering goggles, which when equipped provide you important information when you're looking at certain items like generators and gauges. Next is the wrench, which you can use to rotate, dismantle, and configure Create base items. These two are important, and you should always have them equipped the moment you can make them. Speaking of gauges, I'll also be using the speedometer and stressometer, both of which help you understand the state of your assembly and let you make changes on the fly. Let's get started. Generators provide rotation. Consumers need that rotation to do work. Each generator type has a respective speed and stress capacity. Speed affects how fast parts move. Capacity tells you how many components you can connect before the generator stops working. Here we have a water wheel. With goggles equipped, we can see that the capacity is 256 stress units, or SU for short, which is also reflected in the stressometer. According to the speedometer, it is also currently spinning at 16 RPM. Consumers, on the other hand, have a stress impact, which tells you how much of the capacity it uses up. The total stress impact is determined by a set value multiplied by the speed of the system you connect it to. Take this mechanical press, one of the first things you're going to be building when you're starting out. You can see here that the stress impact is 8 SU times the system speed. The speedometer showed that the system speed is 16 RPM, so 8 multiplied by 16 equals 128 SU. This 128 SU is subtracted to the total remaining capacity, as seen in the stressometer. That means at the speed we are currently at, we can only connect one more before we zero out the capacity. If we go beyond that, the system becomes overstressed and it stops working. The tooltip here shows us two ways we can solve the problem. We can either increase the total capacity or slow down the components. Increasing capacity can be done by changing generators or adding more to the system, which I'll discuss some other time. For now, how do we slow things down? For that, let's go over transmission basics. Take note, transmission items have no stress impact, so you can put as many as you want into the system. For today, we're using shafts and cogwheels. Shafts are self-explanatory, but cogwheels come in large and small sizes and can be meshed together. Small cogwheels can be meshed in a straight line. Large cogwheels can be meshed in 90-degree angles. Both can be mixed and meshed in diagonals. If you have trouble meshing them, hover your cursor over the gear and wait for the white arrow to appear in order to create mesh gears. The cogwheels are the easiest way to change speed. Here we have a simple setup: an encased fan, which is a compact version of a generator, connected to a set of cogwheels and a speedometer. If you use the same size, you get the same speed. If you go from large to small, you go faster. And vice versa. If you go from small to large, you go slower. As I mentioned, stress impact scales with speed, and to show that off, here we have a different setup with an 8, 16, and 32 RPM line connected to a single water wheel. If I connect a press to each line, you can see that the stress impact scales as well, going from 64, 128, and 256 SU respectively. Higher speeds mean that components are able to finish work faster. However, take note that some components have a minimum speed requirement, like this mechanical mixer. shown here that it requires 30 RPM, so let's demonstrate. First, I need to move over the basin since it's needed for the mixer to work, and then put small cogwheels on top. Now I can put mixers on the 8 and 32 RPM lines. You can now see that both are meshed properly. However, when I put the ingredients for sandpaper in the basin, which, happens to be sand and paper, you can see here that the one connected to the 8 RPM line doesn't respond. But the one on the 32 RPM line actually works because it meets the minimum speed requirement. When it comes to making your assemblies, this is the basic workflow. You put down a generator and use transmission items like cogs and belts to connect it to any of the processing equipment you may need. Of course, the mod offers a lot more than just that, so remember to start slow and simple if you're having trouble. That's all for now. Thank you for watching. Hey, so this is Salaryman. This is the part of the video where I ramble on a bit. The video was actually supposed to be a lot longer. I actually intended to cover the overview for generators as well, but the intent was to create a quick and fast overview of the basics, so I decided to settle for just this. It's actually also the reason why I put this part at the end so people can get into it as fast as possible and hopefully be interested enough to listen to me rambling by the end. I was actually working on a video for Vanilla Minecraft, but YouTube recommendations decided that those plans that I had, they don't matter anymore. So I've been pretty preoccupied with the Create mod. The wiki was rather lacking and the tutorials were either kinda outdated, and the more up-to-date tutorials were about more in-depth topics, so I decided to make a video of my own. Anyway, sorry for rambling. If you've got any criticisms or advice on how to improve the quality of the video, a comment would be appreciated. If you got the time, maybe drop a like, perhaps maybe even a subscribe. Thanks. This is Salaryman clocking out.